We have been focusing on using promises, which is the most common thing you will do with the promise pattern. But it can also be helpful to create your own promises. Let me throw out an example. Let's say we have a function that takes a long time to process. We want to be able to have it process in the background without blocking code. This is the type of scenario where we want an asynchronous process. So if we set the function up to return a promise, then we can work with it using an asynchronous pattern. Let's take a look at this. So what I've done is I've created this function here. I've called it inefficient squaring because that explains exactly what it is. Basically, we pass in a number here and it squares the number using for loops. So you can imagine how inefficient that would be. So this takes an exaggerated amount of time to complete, and this allows us to show the type of thing I'm talking about here. This is going to be a process that can take a good amount of time. And we're going to look at making it so that it is non-blocking. Well, down here, I have a console log statement. Finally, I can run. This is to represent other processes that will be running after this function. And we want to see if the function, when it's called using these console log statements here, if this function blocks the code. All right, you can guess at this point that, yeah, it certainly is going to do that. So I'm going to save that with those calls. I'm going to jump out and let's see. Okay, so we've got those all showing up now. Let me just refresh it so we can see how long it takes for each of those console log statements. Each console log statement has a higher number. As the number gets higher, it takes longer for it to process. Especially that last one. See, we're sitting and waiting for that one. It finally shows up. And then that final console log statement that represents other processes that we don't want to block runs. So we want to be able to make this function run in the background. And in order to interface with it using an asynchronous pattern, we want to set it up so that it returns a promise. So that's what we'll do next. But let me first introduce how we even create promises. So I'm going to come down here a bit, away from this other code for a minute. Now, to create a promise, we use the constructor. And as you probably remember, anytime we use a constructor, we have to use the keyword new. So this is the basic pattern for creating a promise. New, and then the constructor for promise. And this will return a promise object. Now, we need to pass something into this. And what we pass in is a function. So we'd have this type of thing. We have a function that we pass in. Now, this function has a specific set of requirements. For example, we have two parameters. We will use two parameters in this function that's passed in. And these two parameters will accept values. And the values they will accept are functions themselves. So we're passing in a function that is going to accept two functions. Now, why are we passing in two functions? Well, if you remember, when we're making use of promises, when we use the then method, we're able to pass two functions to it. The first one we pass in is if the promise is resolved. The second one is if it's rejected. And so those two functions that are passed in using the then method are placed into these variables. And so that's why when we create this promise, we're creating a function here that accepts two functions as parameters. And then we have to code this function that's we're using in the promise here. We have to code it so that it will resolve or reject according to what we need. And so, for example, we could simply invoke the resolve function and we pass in some value. And the value that is passed in is the value that's returned to the then method if it's resolved. Or in the case of reject, the value that is passed in is the value that's returned to the then method if the promise is rejected. And we determine how it's resolved and how it's rejected in the way we write this function that we've passed in to our promise constructor. All right, so that's the basic pattern we want to use when we're creating this promise. Now, I'm going to go ahead and delete this. You know what, maybe I'll just comment it out so you can refer to this if needed. All right. But what we're going to do now is I'm going to apply this up here. So inside of this inefficient squaring function. So we want to create a promise. Now, when we're setting up a function that is going to return a promise, we need to make sure that we return that promise, not just create it, what I've done here, but we need to return it. So I'm going to add the return keyword there. And then let's go ahead and set up our function inside of here. We know we want a parameter for resolve and we want a parameter for reject. All right. And then we're going to develop our function to do something. So here in the curly braces. So this is where we would place our code. The entire code for the function is going to go in here somewhere. We just want to integrate it with the resolving and the rejecting of the promise we've now created. So what's a situation where this might reject? Well, if we're passing in a number here and they pass in something that's not a number, well, we'll want to reject it in that case. So let's go ahead and set that case up first. So we can check to see, I'm just going to use is integer like that to see if it is a number. Now, what I want to do here is I want to negate that, because if it's not a number, then what am I going to do? Well, in that case, I'm going to reject. I'm going to invoke the reject function that's passed in, and I'm going to pass in a value. And what's the value? I'm just going to do not a valid number, because that's a message I want to pass out to whoever is using this function. Okay? So there we have our reject. We've dealt with our reject scenario. And now we just have to deal with the resolve. And so the resolve is going to happen if we do get a valid number. So in that case, we want to use all of this code in here. Because if it is a valid number, then we're going to run through the function that we originally had. Okay, it's going to do all of that stuff. Now let me indent it one more time so we can line that up there. Now, notice what we're doing here. We're returning the result. Now, instead of returning the result, we're already returning the promise up here. So instead of returning the result, we should invoke resolve, the resolve function, and pass the result as the value. So that's what we're going to do. So resolve, and then we're passing the end result as the value. So if it's successful, if the promise is fulfilled, it will pass out the value that this particular function is determining. All right, so we've got this set up so we can use the promise pattern with it. And so what I want to do is I'm going to comment out these console log statements again. And instead of using those, I want to call this inefficient squaring function, and I'm going to pass in this largest number, the one we used down here. This one took a long time, if you remember. So that's what we're going to pass in. Now, this is going to return a promise. So we want to be able to react or respond once that promise is fulfilled or rejected. So first, I'm going to pass in a function. I have a VAL variable to capture the value that's returned. And this is going to be the function that will be invoked if it's resolved, if it's fulfilled. And all we're going to do is simply log that value to the console so we can see what the value is. So this is the function I'm passing in when it's resolved. Now, if it's rejected, here's the function that will be received. We're just going to log an error to the console. We're going to grab the value in the MSG variable and then log that to the console. All right. So here we're set up to interact with that function where we create a promise. I'm going to go ahead and save that, and let's watch over here. It's taking a while, It finally resolves. Now notice what happened. It resolved and we got the value printed to the console because that function we passed in for resolve was invoked. We got that, but notice here, finally I can run. It did run before the promise was resolved completely, but it was still blocked. Notice that if I refresh again, it's not showing up right away. It's being blocked. Then once the promise gets to the point of resolve, it runs, and then we get the resolve callback function invoked. Okay, so we haven't completely fixed this so that it's non-blocking. This is a function that's still going to block other code that's running. So what we need to do in order to make this so it's non-blocking is we need to take advantage of the event loop. We need to use that event loop to help us make an asynchronous process. And then the promise that we've already placed in there will be a pattern that will allow us to interact with, to respond to that asynchronous process. Okay, so the best way to take advantage of the event loop is using a function that uses the event loop, and set timeout is such. That is a very common way to, if we want something to be placed on the event loop so it's non-blocking, so that once the other code is run, it will go back and check that event loop, see if there's something there, and then run that. If we want to make it asynchronous, set timeout is a great way to do that. So let's go back in and we're going to do just a few more modifications. So this is the part that is really intensive. This is the part that is blocking. So here is where we want to set up the set timeout. So when this part needs to run, what we're going to do is call set timeout. And then we're going to pass in a callback function. Remember, that callback function will be placed in the queue, and the event loop will continue to check that queue. When there's no code that needs to be run, it will then call it callback. Okay. Now, if you need to review the event loop, go ahead and do that. Okay, but I'm going to finish setting up this function here. So basically, all we want to do is we want the function to run all of this. So this is the part that's going to run once the event loop calls back to this function that I've passed in to set timeout. That's the part that will run. Okay. Now this should make it so it's non-blocking. So let's go ahead and save that. Look, we've got the final I can run already. So it went ahead and did those other processes. Then when it's done, when that has completed, because of the promise that we're returning, we're able to respond to it. We're able to react to it. So we're using the promise pattern to make it a little bit easier to work with. So there we have an example of where we want to create a promise. We have a function that takes a long time. It's a heavy function, takes a long time to complete. And so we want to take advantage of the event loop and make it asynchronous. And then we create a promise and have it return a promise so that we can respond to it using the promise pattern, which is what we've done down here. All right, let's move on.